going to see a scene. Okay.
First, you need to train your assistant more.
Okay. Can we?
Yeah, but I can see the mouse.
Mouse.
Wait. The system hasn't slept tonight.
Okay.
Alright. Do we still share?
Cannot play.
Nope.
No.
I can't play. But okay.
Okay. Or we can use the other presentation, like this one.
Yeah, it's just
There is the same video.
Just keep going.
Just
okay.
keep going.
Let's skip the movie. Just
Okay.
keep going.
It shows when a soccer is kicked with spin, the rotation of the ball affects the airflow around it, and the soccer's pass may be deflected as a result. If the soccer is not spin, then there won't be this kind of phenomena. There is a physical phenomena called the Magnus effect to explain this. Okay, so what is the Magnus effect? It's a lift force acting on the spinning object, and its path may be deflected in a manner when it's not present when it is not spinning. The force is caused by the Magnus effect is perpendicular to the velocity of the object. As we can see from this picture, there is a higher pressure and there's lower pressure. So the Magnus effect force will act this way. Okay. Next page. Okay. This is my assumptions, and the angular velocity is 20 radians per second, and theta is 45 degrees, and velocity is 30 meters per second, and the mass of a standard soccer is 0.43 kilogram. So the radius of a standard soccer is 0.11 meters. Gravitational force acceleration is 9.81 meters divided by second square. Distance is 10 meters, and air density rho is 1.225 kilogram divided by meters cube. And cross-sectional area is 3.5 times 10 negative 2 power.
Okay.
And the drag coefficient is 0.18.
Okay.
Okay. And I see last page. And we have Vx is about 21.22, and Vy.
So what is 21?
This,
The speed of the ball? Okay.
yes, on
okay.
x-axis.
Okay.
And the drag force is equals to 3.77 newtons,
Okay.
and the force by the Magnus effect is 1.52 newtons. Okay, next. So we can obtain the time by divided the distance by velocity on x-axis, which will equals to 0.74 seconds. And this is my picture about how the forces will act on the ball. And since the drag force will be on the opposite direction of the velocity, and the force by the magnet effect will be perpendicular to velocity. So, and the Fg will be downward. Okay, so we can calculate Fy, all the force on y-axis, by take the sine of Fm and sine theta times Fd and minus Fg. Then we will got these equations. And I use some tool to calculate its maxima for me. So as we can see, it's between -4 and 4. So I would say the value of 1.5 cosine theta minus 3.8 sine theta is smaller than 4. So the acceleration on y-axis will be smaller than minus negative 0.21 divided by 0.43, and which will turns out to be negative 0.49 miles over second square.
Okay. What is the theta at that time?
Theta.
Theta.
Theta. Theta is the velocity and x-axis angle.
Yeah, how many degrees?
How many degrees? In my previous assumptions,
When AY is maximum. Yeah. When AY is maximum.
When AY is maxima. When AY is maxima, here and like.
Okay, go on.
Yes.
Keep going. Yeah.
Okay.
We finish your presentation.
Okay, and delta y will be vyt times t plus 1/2 times ay times t squared, and which will eventually become 9.97 plus 0.11 ay. And we put this inside, so the delta y will be smaller than 9.92 meters.
Okay.
Okay, and the trajectory should be deflect within 9.95 meters, and in the clip above, it deflect about 2 meters when the suckers hits the goal, which is about 2.44 meters. As a result, the sucker's deflection of trajectory in the movie is reasonable in real life.
So it's okay.
Yes.
Okay. Good.
Okay.
Yes.
Okay. And this is my references.
Okay.
Okay. Thank you.
Very much.
Thank you very much.
So, okay, very good, Celestia. It's good you came back and presented. So in your report, can I give you homework? So, okay, say basketball, ping pong, tennis ball, soccer ball, baseball.
Oh.
Which one has the largest, can you calculate Magnus effect for all of them? Which one would have a larger Magnus effect?
Okay.
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 Okay. Thank you very much.
Thank you very much.
Good. And also thank you, David.
Thank you.
Okay. Yes, yes, thank you very much. It's good you came back. I really like that.